So hello everyone. Today we will discuss the problem of another. Today we will discuss the problem of integral. So let's see. So in the question, we have to find the integral of root tan x plus root cos x. So there are two different methods to solve this problem. So first method is I'm proceeding with first method. So I integral is equal to we know that tan x is equal to sin x upon cos x. This is the basic formula, and cot x is equal to 1 upon tan x means cos x upon sin x. So it will be sin x divided by cos x plus root cos x divided by sin x dx. Now we can take LCM also. So if we take LCM, then LCM will be root sin x into cos x. And so in the numerator, it will become root sin x will become sin x plus root cos x becomes cos x dx. Now what can we do? We simply multiply by root 2 on numerator and denominator. So if we multiply by root 2 on numerator and denominator, then it will become like this: 2 sin x cos x in the denominator. Now 2 sin x cos x is nothing but sin 2x. So in place of sin 2x, or we can say 2 sin x cos x, we can also write sin x plus cos x ka whole square minus 1, or 1 minus sin x plus cos x, sin x minus cos x ka whole square, like this. Let's see. 2 sin x cos x can also be written as sin x plus cos x ka whole square minus 1, or 1 minus sin x minus cos x ka whole square. So we can write 2 sin x cos x as this or this. Both are equal. Both both equations will give me 2 sin x cos x. So what can we write? This or this in the denominator. So if we take this, then if we put t is equal to sin x minus cos x, then we will get the numerator, desired numerator. So sin x plus cos x. So our I will become root 2 sin x plus cos x as it is, divide by, instead of 2 sin x cos x, I'm writing sin x minus cos x ka whole square dx. Now if we put t is equal to sin x minus cos x, then let's see, put sin x minus cos x is equal to t. So dt by dx will be, means differentiation of t with respect to x, means sin x ka differentiation cos x minus cos x, differentiation of cos x is minus sin x. So minus minus will get cancel out, and we will get plus cos x plus sin x. So dt will become sin x plus cos x dx. So our integral will become root 2 times dt. Instead of sin x plus cos x dx, we can write dt divide by root of 1 minus, we can write t in place of sin x minus cos x, so 1 minus t square. Now this is the famous integral. We must know about this integral, 1 upon root of a square minus x square dx. So its integration will be sine inverse x upon a plus c. So here we can say that a is equal to 1, so we can also write 1 as 1 square. So I will become I is equal to root t sine inverse t upon 1 plus c. So I is equal to root t sine inverse, and t is what? Sin x minus cos x plus c. So this is the first method to tackle this problem. Now another method is method 2. We can also done this integral by another method. Let's see how. So root tan x will remain as it is, plus we know that cot x is 1 upon tan x. This is the basic formula of trigonometry, so we can write it as 1 upon root tan x. So 1 upon root tan x will give us root cos x. Okay. So now I'm putting tan x is equal to t square. Put t is equal to tan x, t square is equal to tan x, so that this rule will get vanished. So we will get 2t dt is equal to sec square x dx. Now there is only dx, um so this sec square will be come in the denominator. So 2t dt divided by sec square x is equal to dx. Now we know that sec square x is equal to 1 plus tan square x. This is the identity of a trigonometric identity it is. So sec square x is equal to 1 plus tan square x. Okay, we know it very well. So 2t dt is equal to 1 plus tan square x, and tan x is what? T square. So tan square x will be 1 plus t की power 4 dt is equal to dx. So our integral will become I is equal to root of tan x means root of t square means t plus 1 by t, and in place of dx we can write it 2t dt upon 1 plus t की power 4, 2t dt upon 1 plus t की power 4. Okay, so now uh, we multiply t by this t in the bracket, so it will become t square plus 1, and 2 is constant, so it can be right outside the integral. So 2t dt, so sorry, t square plus 1 dt upon 1 plus t की power 4. This is our aim to solve. So now we can now if we multiply by t square on numerator and denominator, then we can easily solve this problem. Then we can further proceed easily. So I'm dividing by t square on numerator and denominator. We will get, हमें अब क्या मिलेगा? We will get I is equal to 2 times t square plus 1 by t square 1 plus t की power 4 divided by t square dt. Now we can write it as t square 1 plus 1 by t square in the numerator, and 1 upon t square plus t square dt. So 2 times we can write it as 1 plus 1 by t square as it is, and in the denominator t minus 1 by t ka whole square plus 2, and it is equal to 1 by t square plus t square. If we open the square of a minus b, then we will get t square plus 1 by t square. So if we put t minus 1 by t is equal to u, then du by dt will be 1 plus 1 by t square, and du will get 1 plus 1 by t square dt. So I will become 2 times du divided by u square plus 2. This is also the famous integral 1 upon x square plus a square is what? 1 upon a tan inverse x upon a. So 2 times 1 upon root 2 tan inverse u by root 2 plus c. So it will be root 2 tan inverse times t minus 1 by t divided by root 2 plus c, and t is what? Root tan x. So we can write it here root tan x. So root 2 times tan inverse root tan x minus root cos x divided by root 2 plus c. So this is also the answer of our given problem.